Hope you're ready to learn something about event sourcing, or maybe you know everything already. Let's see. What I found is there's not many talks, or there are many talks about the theory around event sourcing, not that many talks about the code that you have to write for it. So I thought, let's see if we can demystify a little bit of that, and then see if you can get a feel for what that kind of code means. I'm Nico Krijnen, I work at Luminous, and my mantra is to try and find simple solutions, even when you're facing complex problems. And after this morning's talk from Hadi, I had a bit of a feeling like, I'm talking about event sourcing. Is that really finding simple solutions? Maybe not, right? So, maybe to figure it out, we need a little bit of additional wisdom in the room. So I brought my co-host for today. He's going to help us find the right solutions. Let's see. What do you think? Warm welcome for growing people. So what can you expect? So I'll first do a short dive into the concepts that we're going to talk about so everybody can follow along. Then we'll do some digging into a domain, because that's important if you do event sourcing, and you'll see why. We'll show some code, right? Because that's what it's all about. And we'll also show why Kotlin shines in this context. And we'll also talk a bit about the need for frameworks. Or not. So concepts. Let's start with commands. And when I talk about commands, I'm not talking about the gang of 4 command pattern. That's something different. It's commands as we use them in some of the other patterns we're going to talk about. And in that sense, a command is essentially something like this. You have a function, you call the function, it's called register user, you pass in an email and a password. So you can do this as a function, or you can wrap these 2 arguments, or more arguments, into a command. And what does it do? You create a small data class in Kotlin, and just pass that one command into the function as a single argument. And it gives actually quite a few nice benefits. So one of the key benefits here is that you capture the intent of what someone is trying to do. So you're not just passing some arguments, you're capturing the fact that someone's trying to register and that they passed in this information. Then what can you do? You can pass that along, all that information along a whole chain of functions, a whole pipeline if you want to, without having to modify it. But you don't have to pass along all these parameters. If you want to add a parameter, you add it to the data class, and it goes along the whole chain. You don't have to add stuff in the whole chain. And then, because you capture all this information, you can delay them, you can queue them, you can replay them, retry them. So there's a lot of nice things that happen when you start capturing the intent of what someone's trying to do in these commands. Then, if you're naming these things, there are some good advice here, probably from Grow, I guess, is to use naming that captures the intent in the language of the domain. So don't use something like create user, but use something like register user, or don't say update address or update product, because probably you're not updating one single thing, or you're not updating the whole thing at a time, you're updating specific things. You're trying to do something like increase the inventory, which is something else than updating the product. So making that distinction allows you to better understand what someone is trying to do when this command comes in, and also means you can optimize how you deal with it. So next up, events. So events are very similar to commands, but as you can see here, we define an event as something that happened, and that's really important. So an event is a fact that happened. It has happened. It's not something that's going to happen or anything. An event has happened. So it's someone, like a user, registered themselves, or maybe the inventory was increased, or maybe someone moved and changed their address. And some common fields that you also see around events are things like a timestamp or an event ID. I left them out here, just otherwise it doesn't fit on the screen, but those are very common properties for events as well. And then you're wondering, I just saw these commands, and then I see these events. What's really the difference? I mean, can anyone tell me what the difference between these is? Cause and effect, yeah, someone else? So the command is what triggered the action, and the event is what the fact that happens, right? So the difference is really their intent, right? Apart from the name, right? You see register user command and a user registered event. So the naming is slightly different, but the properties are usually quite similar. But their intent of these classes is very different. So you don't want to use commands in place of events and mix them. And then if we're talking about events, like in our systems we use events in many places. And we call a lot of things events. So I did a workshop recently, and we were also talking about events, and someone said, like, are we talking here about mouse clicks and those kind of things? No, that's a very different kind of event. What we're talking about here is what's typically called domain events. But there's many other types of events around there. And you don't need to know about all of them as long as you know that there are different types of events. And you don't need to treat all of them the same in your application. You need to separate them. Okay, next concept. We're going through them fast here. So CQRS, this is a quite interesting technique actually. So say you have a typical application where you have some UI talking to some services, which use a model, and then you store something in a database, right? What the guys from who invented CQRS came up with is you can actually use different models for the place where you're doing modifications, where you're writing stuff, and for the place where you're querying, where you're reading stuff. And by splitting this up, you can optimize each of these models. So the write side can be optimized really for writing stuff, can be consistent on that side, and then the query model can really optimize the way the model is built for the stuff that you want to display on the screen. Just the stuff you want to have there, you put in your query model, the way your queries work, you put in there, but you don't concern yourself with all the complexity that's also living in that command write side. And this can simplify both sides, actually. You can go a step further, and you can use different databases for your write and read side. So typically you put some events in between, so the command model dispatches some events, you have a projection that then translates that into the read model that you want to have, and you can take this even one step further, and you can have multiple read models if you want to have multiple of them. So why would you even do this? Because this picture looks a lot more complicated than the first one. Well, maybe you have different scaling needs. Maybe your write side is doesn't have many actions, but your read side has many millions of users. Then that's a good reason for separating them, right? You get to the previous picture. For this one, well, maybe you have very different kind of queries. Simple queries that you can do with a simple database, or maybe you have something where you need Elasticsearch, or maybe you have, like what you see with DynamoDB, for example, you have, for every query, you create an optimized read model. So those are the kind of things you can do here. Right? Once you understand that you don't have a limit on the amount of data you can store, then you can end up with these kind of models. But then, do you really want this, right? Because this sounds like, ooh, that's cool technology, but are there any benefits? Right, because the one on the right feels a lot simpler, right? So actually that is true. The one on the right is very simple. You probably have a lot less code, you probably have a lot less complexity. But on the one on the left gives you more flexibility. It may result in much simpler queries because your query model is really optimized for those queries. And you maybe actually have a simpler write model as well because it doesn't have to contain all the stuff you need for querying. So this is something you have to figure out for your application, but it's good to know that it's possible. So now we get to event sourcing. And to me, like once you've tasted this, you really won't be able to go back and unlearn this stuff. So traditionally, when you change data, like you change the address of someone in your database, then you replace it, right? You update the record, and you don't know anymore about the old state. And for many applications, this is totally fine. So you should absolutely do this, right? But you are deleting data at this point. And if you ask your business, is it okay that we delete our data regularly? What do you think they'll answer? Right? Probably yes, because otherwise you wouldn't be doing it, but, well, there might be quite some cases where actually it's probably a better idea to keep around where someone is before they moved. So people came up with event sourcing, where you don't store in your database the current state, right, the latest state, but you actually capture all the events that happened. So we're back at the events we talked about before. You store everything that happened, and if you need the current state, you just build it up by replaying all the events and figuring out what the latest state is. Now that's a quite interesting concept, but when should you use it? So you should use it when time or history is important. Guru, what do you think? Maybe, right? Because it does add complexity, and you can do a lot of times in history stuff in a normal database as well. But if you use this concept, you have that whole rich history there, and you can use it. Then what if you want to adjust behavior after the fact? Something really interesting happens when you have the whole history of stuff that happened, is if you find a bug in your system, you can just replay all of history and fix the bug, and the bug is fixed also for the historic stuff. Now that's quite interesting, because in a normal database where you overwrite stuff, it's overwritten, it's gone, right? The old stuff is gone, you can't fix anything. Here you can have the possibility to change and fix stuff. Obviously you can't change it by changing your events. No, you just have to create new events again to update the state. But you still have all the history, and it's really powerful. So in those kind of cases, yeah, probably event sourcing is a very useful tool. And when you need an audit log, right? Because you have all that history, that's a nice place to use event sourcing. Well, actually, probably not, because an audit log, you can create an audit log quite easily with just a table where you log every thing you do. You have an audit log, and that's much simpler than doing everything event sourced. Okay, so now we get to an interesting part, understanding a domain. Because as you can imagine, the added complexity of event sourcing usually is useful when you're dealing with a more complicated domain. And when you're dealing with a more complicated domain, it's worth understanding how it works. And then you get to techniques like domain-driven design, and in there you have a nice technique, or related to that you have a nice technique called event storming, which is a workshop where you get the right kind of people together that know about the domain. You take away all the chairs in the room, you give them a big space on the wall to draw or put stickies, and you just put them in there and let them figure the problem out. And there's some guidance there, but in the end it typically looks something like this, or something like this if you're in a lockdown, right? So let's go and explore the case of renting Lego stores. So who of you have ever rented Lego? Wow, that's interesting, right? I didn't know, but this is a whole business. There's many websites, even just in Holland, many websites offering this. I'm not sure if it came up after or before. It existed before Corona already, but yeah, this is a big thing. So probably look it up. This is possible. So how does this work? Well, first, we're going to put all the events on our timeline. So we create a timeline in event sourcing, in event storming, and we put down post-its with all the things that happen. Right? These are these events that we're talking about. So someone wants to build something, they browse a bit, nothing's happening at that point, right? They're just looking, but at some point they're going to book a set. That's an event. Well, when they have booked it, right? Then they're going to pay the fee, the Lego gets shipped to them, and then when it's maybe low on stock, the store needs to refill, and then when I finish my build, I'm going to post photos, because I'm proud, obviously, and then it gets returned to the store. So this is roughly what the process looks like, and then we're going to enrich it. We're going to add the commands, like what are the triggers for these events. So we add all these triggers, like someone books a Lego set, and you can all sort of see a pattern here. For every event, there is a command. And there's a few other things like policies. I'm not going to explain them now, but there's other stuff that happens as well. And then you're going to add actors. So who did this? So who triggered it? Was it someone like a Lego builder, someone who wants to build Lego sets, or was it the Lego store who shipped the set? So this kind of information is quite useful to know. And then you're going to figure out, okay, what is it acting on? So booking a Lego set has to do with the Lego set inventory, and sharing your Lego build photos has probably something to do with the Lego build gallery. So you start to see a picture of how this all ties together. And with such a workshop, you get quite a bit of insight in how the process works and what is associated with it. And you can almost see the classes already, right? You can see which commands you need to create, which events you need to create. So it's quite a useful technique. So let's go to the code. And I'll start with some diagrams because then you understand a bit better. At least I always work visually. So what we start with here is we have an API to book a Lego set, which sends a command to a service to handle that command. And that service will grab from an event store, which talks to a key value store in this case, it grabs the current history of events for that Lego set, and it loads it into memory. And then it passes that Lego set into, well, in this case, the Lego set service, which has a Lambda acting there, which then creates an aggregate. This aggregate is like the object that represents all the business logic that you want to do with these Lego sets. And you pass in the constructor this history of events. And then we call a handle function with the command that we want to handle. Then this aggregate can do all its business logic, and we'll look at it in a bit. And it returns the new event that resulted from that action. So it doesn't write anything to the database. It doesn't do anything. It's just, in that sense, sort of almost a pure function. It doesn't do anything. It just returns you a new event. And this is quite interesting because it allows you to unit test the whole thing quite easily, right? You create aggregates, you put events in there for current sort of states that you want to be in, and then you send some commands to it, and you check if it returns the right event. That's all you need to do. So that goes back to the Lambda. The Lambda sends it back to the event store, and it appends it to your key value store. And you have a new state of history. So let's look at that in code. Oh, no, I don't want to join the Wi-Fi here. So we'll start at the Lego set service. We have this handle command here, and we can see it as being called from an API here. This is a simple Ktor API. Not going to go into details here, but it calls this handle command and creates that command and captures all the parameters from our incoming request. Then this talks to our event store, and it says handle mutation. And this is an interesting function because it accepts the ID of the aggregate. It accepts a function or lambda that produces new events. So let me go to the implementation of this one. So aggregate ID comes in, and we say, give me something that produces new events based on existing events. And it can be whatever we want, right? So this will return new events. So this part, it just gets a stream of events for our aggregate from our key value store. This goes and talks to our key value store. Then we call that function. We pass in the events. We get the new events. And then if they're not empty, then we write them. Right? We append the new events to the key value store, and we publish the event on our event bus. And someone should have a question at this point, but I'll answer later, because this is a problem. But we'll see later why. So back to the service. So that's what it did, right? It passed in this function, and I assume you all know Kotlin. So this is a lambda where we get these existing events. We then create that aggregate with the events, call the handle function with that command, get the new events, and that's what we return. And obviously, we can just write it like this, but, well, for this time, I use it to like this, so it's a bit more readable. And then if we go into the handle, we look at this part where we're inside this Lego set aggregate. And I'll go through this shortly. We'll dive in it a bit deeper in a moment. So as you see in the constructor, we get the list of events. We just make sure that we're not getting anything that we wouldn't understand, like we expect that the Lego set add to catalog is the first one, and then we also don't, or it should be empty. We have a few properties that we use later on. And then we have this handle, which first checks that the command is actually for our aggregate. Otherwise, we're going to fail. And then it applies a handle command here, which then wends over the different types of commands that we have. And let me actually show you the command definition. So here we have these commands defined. So let's go back. And then we have just a simple function for each of the commands that we can handle. So let's go into the book set one. And then first we check if it's available, right? Can we actually book this set? Because if we don't have any in stock, then it's probably not wise to book one. And otherwise we fail. And if it's all good, then we just return a new Lego set booked event, and then our aggregate is done, and this gets appended to the event history. Now, how do we? Because we were talking about we don't capture the current state, right? So we need some state here because we need, for example, the state about whether the set is available. So how do we know if it's available? Well, we have a property here which is calculated based on whether we have anything in stock, and that amount in stock is actually derived from the events. So this looks at all the events that we have in our history, goes over them, and starting with 0, for every one that affects our inventory, we're going to add that amount changed, which can be positive or negative, to our result. And then, obviously, in the end, we have how much we have in stock right now. So this is how you build up state. Now, on the projection side, say you would want a report on stock over time. You have all these events, so in theory, you could listen to all these events, and you can build a nice graph and report about how many you had in stock for this Lego set over time. But that's a very different model, right? So that has nothing to do with the state you need right here, because we don't need to check it right here, so we don't keep it in here. We keep that in a separate read model, optimized for keeping all the state for that report. But it can use the same events to gather that. Okay, so far for this part of the code. And then it went black. Let's try again. There we go. So if we're talking about event sourcing and Kotlin together, why is Kotlin such a good match for event sourcing? At least why do I think so? And why does Grogu think so, right? Because he's the expert here. So to start with events, as you may imagine, they're facts that happen in the future. Can we change the past? No, we can't, right? Facts are immutable. And so are default data structures in Kotlin. That's nice. So let's look at an example. So here we have a Lego set booked event with a few more properties. And this is what it looks in Kotlin. This is what it would look like in Java. Now, it's not actually that bad because we're using a record here. Yeah, sure, if we want the same nullability, we have a few more annotations and some checks we need to do. But actually, if we take away these checks, it's pretty much the same, right? It's very concise already. If you're out of luck and you're in an older version of Java, yeah, well, that's why record is there, or that's why data class is there. So you can already see why data class is really nice to have if you're building these kind of systems. So if you look at this, apart from the vals, you can't really write it any way shorter, right? You need the name of the event, you need the names of the properties, and you need the types of the properties. Well, that's pretty much what you're writing here. And because it's so concise, you can use something which you can do in Kotlin, is you can put multiple of them in one file. And that's quite nice, because if you have your events, all of the events for one aggregate in one place, you have a very good overview, not just of the names of the events you have, but also of the properties that they have. Maybe if you want to add a property to a few of them, you can easily check if you missed one. So this is a really nice way to do this. And obviously you can also, if it gets a bit out of hand, you can always split them up again into separate files. That's something you can always do. But having this ability is quite nice. And obviously you can do the same with your commands as well, right? Just create one file for your commands. In some cases, if you only have a few, maybe you even put your commands and events in one file, and you can see them side by side very nicely. The another trick you can do in Kotlin is using sealed interface or sealed classes as a base interface for the commands that you're using. And this allows you to then in a when statement, like you saw in the handle command, to go over the different types of your commands or events and handle each of them as you would want to handle them. And if you add a new command, the compiler will force you to add a new statement here as well. Then, let's say the more functional side of Kotlin is quite nice as well, I think, in this state, because with building state from your history, you get a lot of places where you're going to have functions to essentially build up state from the list of events. And then using an extension function like you have here, like an extension function on the list of events to build up some state. And then you can use something like fold in this case to reduce that to one single value, like the state that you want. So I think this functional style and also extension functions really make this very nice and very readable, because then you can do something like events.amount in stock, which is quite easy to understand if you're looking at it. But you can see the relation that the amount of stock is coming from the list of events. And then, again, you can use properties to capture that state, and then use those properties all around in your aggregate where you want to check on the current state, which is, again, quite readable. And another nice thing that you see here is the use of lazy properties. I don't really use these a lot in other pieces of code, but I found them quite useful in this event sourcing case, because your events are immutable. This list that comes into your constructor is all immutable. So it's quite possible to cache these values. There's no danger in caching them. And if you want to calculate all the state at the start of your code, then maybe you're calculating a lot of state that you're not going to use, right? Not every handler is going to need all the state of your aggregate. This way, in this case, if we use the available property, it will calculate it, it will cache it. If you use it multiple times, it only gets calculated once. And yeah, and readability-wise, it works quite well as well. So, what about no frameworks? Because that looks simple enough, right? Do we need a framework to build that kind of code? You just define some commands, you define some events, you create a pipeline to handle the whole mutation part. You create some aggregates with your domain logic, and then you build some projections for your read models. But there's a few things we didn't talk about yet, and they're a bit too big for this talk, so I'm not going to go in depth. But what about dealing with replays? But what if there's a bug and you want to replay those events and fix them? Yeah, that's not easy, right? That's sort of opening Pandora's box there. Dealing with eventual consistency. That's not easy. I mean, there are patterns out there to deal with this. For example, you can add a little bit of wait delay when something's doing a call or doing a query right after they've made a change. And then for that user, you wait until their event state has been going through the projection, and then you can do the query. But there's a lot of stuff you need to build to deal with that. And then if you have a write model and the event publication, which you saw in the code, right? There was a piece writing the new event to the key store, and then another line afterwards publishing it on the event. What if your application crashes in between? Then your event was not published. So again, there's a pattern like the outbox pattern that you can use to fix this, but you'll have to build it. So there's quite a few things you would have to do, and they're not simple things. So that sounds like I need a framework, right, Grogu? Yeah. So let the framework solve all these hard things, and you focus on your aggregates, on your domain logic. And then some of these frameworks, they really have a lot of options on choosing underlying technology. So you can choose a key store or an event store or a relational database for your event store, whatever you want, right? So there's a lot of stuff here you can do. Some are a bit more intrusive. Some require you to put annotations all throughout your code base, even in your domain, in your aggregates. So yeah, that's a choice if you want that or not. Some of these are more like full-fledged IDEs, where you just define the events and you define the projections you want to do, and the whole system takes care of it, everything. That's quite nice. And you just sort of declaratively define what your model looks like, and it just works, almost like magic. And then there's just libraries like Occurrent, which take like unopinionated view. They solve the stuff, the hard stuff, and they try not to get in the way of your domain logic. But they're probably not as full-fledged as some of these other ones. So, we should use a framework, right? Well, that depends, right? Because frameworks have an opinion, and do you really agree? So you have to think about this. And as I said, some of these frameworks can be really intrusive, right? You can really never get rid of them because they're all throughout your code base. And I personally don't really like that. And sometimes frameworks add complexity that you may not need. Right? If you're never going to change, like Hadi said this morning, if you're never going to change your backing database, then why should you have all these adapters for it? Right? Who cares about that? So, recap. Do we like event sourcing? Grogu, what do we think? Do we like event sourcing? Yes, we do. Yes, we do. Should you use event sourcing? Yeah, maybe, exactly. It depends. It depends, right? So yes, you should use event sourcing because it's not that scary. I mean, the code you just saw, was that really scary code? Not really, right? Quite easy to understand. I'm pretty sure most of your colleagues will be able to understand once you introduce that. But yeah, there is some complexity with all the stuff around it that you introduce that may not be what you want. So only use it if you really need it. I said that would be my advice. And framework? Or is just plain Kotlin code enough? What do you think? So, well, plain Kotlin is probably not enough, right? But yes, it is enough for your domain. Really, that aggregate that you saw, that's just very clean, simple. It's just Kotlin code. You just put events in, you get events out, you put commands in, and that's it. It's nice and pure. Just keep it that way, right? Don't put your framework in there. So, event sourcing with Kotlin. There you go.
Good.
So now, Grogu, I think we have a bit of time for questions.
Yeah, we have some time for questions. Any questions for Nico? I'll walk this way first.
Thanks. I just want to ask about, because actually what we've seen now is it has to be done even if we're going to use a framework in any kind of language. But there is very important points in any event sourcing application, like the event pass. And usually we need internal event pass, that not external. I'm not talking about like event pass external, like Kafka or something, but we need internal event pass. And there is a hell about evolving of the events. So in Kotlin, is there a way to handle that event pass part? Like, is there kind of internal event pass, or still I need to use a framework like Guava, for example, or some?
Well, I'd say if you want to, let me just open up the event bus. There. So, I mean, in the end, the event bus is not much more than a set of subscribers, right? You can add them, you can publish events to it, and when something gets published, it sends it to all the subscribers. And the subscribers are just something that accepts events. Right, this is pretty much your event bus. So do you need a framework or something for this? I don't think so, right? At least not for your internal part. Right? But maybe you want to have your events in a durable event bus. So then probably you should put some interface, or you can implement the same interface and put a durable event bus behind it. But just for inside your application, keep it simple. Right? And then you also mentioned like evolution of events. What if an event changes? Right? You can't change your old events. That's never possible, right? Because they happened already. So what you typically do is you create upcasters or something like that. So you create functions that accept the old type of event and they transform it to the new type of event. And then in your system, you only have to deal with the new kinds. And obviously, when you read events, you can just translate or put it in between and translate them all to the new type of events. And then you only need to deal with the new ones. And yeah, that's just a little bit of code that knows how to translate them. Yeah, so every time you evolve, you have to add that. So again, that's a bit of a complexity that you're adding, but you don't need a framework to do that. You can do that with a few functions.
Thanks.
Okay.
Good one. More questions?
More questions?
That way.
Hi, Nico. My question is, will you say that this event sourcing with CQRS it's scalable? Because I am asking this because despite has a very nice separation of concern architecture, but you have the concept of aggregate, no? And in my experience with Axon, the aggregate was a singleton, so it couldn't scale. Will you say that implementing this without a framework, maybe with Kotlin, will scale better?
It depends on how you approach it. So what you typically see is that, for example, you could, the way you do the mutations on your aggregate, you don't want to have multiple of them running at the same time, right? So you could do something like a single-threaded processor for that, and then it becomes hard to scale. But you can also use something like optimistic locking, where when you read from the event stream, you take the version of the events at that point, and then you do your modification, and when you write them back, you include that version. And if it doesn't match, then you fail, and you just load the events again. And then the nice thing is you have this command, which captures the intent. So you take the new history, you put the command into your aggregate again, and you see what comes out. And then you try to write that, and if it fails again, you retry. So you can do this kind of retry with optimistic locking, and I think it can scale quite well, to be honest. Another aspect on scalability is like how easy can you change or modify logic. And I think a nice thing about this approach with commands and events is that it's quite easy to add events, add new commands. So if you add new behavior, it's quite modular, right? You just write a few events, a few commands, some handlers, and you're pretty much done. And it's not like you have to go and modify a lot of classes for this. It becomes nicely decoupled. So I think this architecture does help with creating a loosely architectured code base.
Thank you.
Thanks, man. More questions? All right, then give it up for Nico again.